All right, so welcome to the coding section of our day 3 lecture. All right, so the first thing I need to do is to open up the folder where I would like to carry out this coding, and then copy the path to that folder, and then go straight to Anaconda prompt and then activate my environment. So this is the root environment of the system. I need to navigate to my environment I created by activating my environment. So I'm going to type activate my environment, and then I'm going to navigate to the D, to the local D. Then I'm going to change that to my working environment, which is the working directory. Then I'm going to initialize the Jupyter notebook from this point. I'm going to create a new script. I'm going to call that script day 3 underscore ML project. And hit the rename button. All right, so what we're going to be doing in today's coding class is feature engineering for household power data. All right, so this is the coding section for the lecture we had in day 3. All right, so the first thing we need to do, we need to import the libraries that we need. All right, so the first thing we need is importing pandas. So we're going to say import pandas as PD. Then we're going to run this cell. All right, so Panda is used for loading and manipulating structured data. In case you're asking, why do we need pandas? Now, let me tell you the objective of this coding class. Now, the purpose of this coding class is to provide a line-by-line explanation and process on how to engineer features from a clean household in order for we to create or produce a new data set which is clean, all right, which is clean and free from some forms of inconsistency. All right, so let's keep it that way. All right, so the next thing we need to do is to load the data set. So we're going to define this variable, which is df, which we normally use as data frame. So df equals to, so you can use any variable just to store whatever operation you want to perform. So let's say df equals to pd dot read underscore csv. So this is the method csv that allows us to read our structured data in txt or csv. Now, before we continue this has to be the continuation of the seminar we had in day 2. All right, so that you don't get confused at any point. Now let's go over to the seminar we had in day 2. Right, so in day 2 seminar, this is what we did in day 2 seminar. All right, in day 2 seminar, we tried to perform EDA, which is exploratory data analysis, and we carry out all of this. We read the data set. This is the raw data which is in txt, right? And then we perform some operation to view, get some information about the data, and then get rid of the missing value by dropping them, and then we're able to check if we still have missing values. And after getting rid of those missing values, we had a clean data, all right, so which is known as this df underscore clean. So this is the clean data. So this data is free from missing data points. So we need to save this data so that we can use it for day 3 coding. All right, so since we have this data, all we need to do, we need to save it. All right, so what you need to do at this point is to save this data, right? So I'm going to prefer we save this data as CSV. All right, so we're going to use this code to save the clean data. So it's going to be df_clean dot to CSV into bracket the name, the file name, which is energy_data_clean. This is the file name, and the extension we want to save it is .csv. So we have specified the name and the extension of the clean file. All right, so the next thing we want to do, we want to maintain the same delimiter as the original data set. So we're going to use the delimiter as a separator. So we're going to say sep equals to semicolon. And then we introduce another argument that says index equals to false. And the reason why we do this because we don't want Pandas to introduce another extra column in the data set. So we set that to false, or else Pandas is going to introduce an extra column with index. Right, so set that to false. So once we do that, we're going to have a data set saved. All right, so once that is done, then you're going to see this data set saved. So once you run the code, you're going to find this data set, which is the CSV file, right? So I did it twice using different format. This is the .txt. So we're not going to be making use of the .txt. So we're going to be making use of the CSV file. So this is what we're going to be calling in our day 3 coding. So let's go back to the day 3 coding. All right, so this is the day 3 coding. So in this case, we have to load the clean data that was saved in day 2. Okay, so we have that underscore data underscore clean dot CSV. Then we have the code, comma. Then we need to indicate the separator, which is a delimiter. Right. Then let's run this code. Okay, so we didn't get an error, so it means everything went well. Right, so the next stage we need to do now, we need to define numeric columns. Now we're doing feature engineering. We have to scale the features, we have to convert them into a consistent data type. We have to use the standard scalar, mini, max, normalization. We have to perform all of these things to maintain consistency, and also need to extract some information from the datetime as well. All right, so let's begin by defining the numeric columns. All right, so we're going to say numeric underscore columns equal to, so we're going to have all the column names. Okay, so in that case, what we can do here is to use this to get the column names, because typing this is going to take all right, so we have all these column names. So therefore, since we have this name, so that makes it easy for us. So we're going to say numeric underscore columns equal to, so we're going to copy all this to this part, and that's going to save us. Okay. So that means we've gotten the columns name. So we have all the columns name, okay, excluding the date time. Right, so in this case, all we need to do, let's run this part. Now, the next thing we need to do, since we have specified the list of numeric features to be converted and used for further processing. So it is this column we want to convert because these are the columns that have the major features. We want to convert these columns, okay, for further processing. So the first thing we need to do is that let's convert the data types, right? So we're going to say df okay, column, we have this equal to, we're going to have df, okay, this is the numeric columns. Then we're going to say dot as type. What data type do we want? Float. And so we're going to convert this all to float. So if there are integers, it will be converted to float. And then float simply means you have a digit with a dot, with a point. Okay, that's 1 point, 2 points, and that indicates that it's a float. So everything has to be converted to float. So if this is done, then let's run the code. All right, means everything went well. So what we have done in a nutshell is that we have converted the selected numeric columns to float type to ensure compatibility with mathematical operation, because when we carry out mathematical operation, we need to ensure that there is consistency and compatibility. So that's why we have to convert all those numeric features into float. First and foremost, we identified it, and then now we are converting them into float. Right, so the next thing we need to do is to convert the date time column, okay, to date time format if it's not already done. And also in order for we to also prevent errors, right? So that's the next thing we need to do. So we need to say df, then we have code, we have the date time equal to pd dot to underscore date time. Then in that case, we need to specify, say df, what is the column name? Okay, so the column name is date time, comma. Now, if there are errors, it should undo the error. So we say errors. All right. So once that is done, so the next thing we need to do is to run this line of code. All right, so we have one error, meaning that we don't have a code on this part. It shows this error, means there's something wrong at the end. So let's run that, and then we have corrected it. So the next thing we need to do is to extract date time features. Now we need to be able to extract hour out of the date time feature. We have the date time feature now. We want to extract hours out of it so that we can be able to identify and scrutinize which hour of the day do we experience surge and spike? Okay, which hour of the day do people consume much energy? So we need to be able to extract that feature, the hour. Okay, and then next we'll extract the day of the week is Monday, Tuesday, Wednesday, Thursday, Friday. Let's also check which of the days of the week do we have huge amount of power consumption. So these are things that will help us streamline our scrutiny, our investigation, and then gives us a better insight to people's behavior in terms of energy consumption, to consumption behavior and all of that, and pattern of usage. And so that's the next thing we need to do. Right, so all we're going to do at this point, we need to say df, right, so which is the column we want to create. We want to create the R column. Okay, now we're going to create this R column by extracting, okay, extracting the R from the date time. So in that case, we're going to have this. So since it's going to be a column, its a name is string, we need to introduce the code. Since it is string, we say equal to, and then we introduce df, which is the existing column we have in the data set. All right, say code, we have date time, okay, as a column name. All right, so we have specified that. And then the next thing we want to do, we want to extract. So we say dot dt dot r. So this is going to extract the r from the date time column and then store it into this new column we have created, which becomes a new feature. So in this case, we are engineering new features. So now once I run this, I shouldn't have any error. And then I have to also do this for day of the week, right? So we can also extract day of the week from the existing feature that we have, which is the day time. So the column already exists in the data set. So all we need to do is to engineer a new column, which is going to be day underscore of underscore week. All right, so once we do that, we're also going to be extracting it from the date time column that already existed. And then this will become .dt.day underscore of underscore week. All right, so once we run this code, we shouldn't get any error. But if we do, we'll have to fix it. All right, so that's being done, we've been able to extract this information. And if we have to display what we have, df, and then run, we're going to see that we have included we've included two new columns. We have hour and day of the week. Now, let me also explain what you can find under the column day of the week. You have 5, 5, 5, you have 4, and thereabouts. Right, so let me explain to you what that means. Now, what that simply means is this. The extracted day of the week is done such that it assigns 0 to be Monday and then 6 to be Sunday, meaning that where you have 5, that's Saturday, and where you have 4, that's Friday. So it follows the standard Python numbering, which starts from 0 and then progresses that way. Right, so that's what we're going to have. So 0 is going to be Monday. So we have the numerical representation of the day of the week. Right, so the next thing we need to do feature encoding. Right, we need to do encoding. We need to encode these features into digits. Okay, we need to begin to encode them into something that the model can understand. Now we're going to import NumPy, which is going to use for creating cyclic time-based features, which is sinusoidal encoding. So this will help us create the cyclic-like nature of time, where time moves from 12 in the noon, goes back to 12 midnight, and then continues 1 midnight, and then go round to 12 none. So the cyclic nature of time, that's what we're trying to implement here. So we're going to be using the sinusoidal encoding to do this. All right, so let's continue. So all we need to do is to import the library called NumPy. So NumPy is going to help us with this numerical computation as NP. So run the cell. Now we're going to say df. Okay, so we need to create this future, which is r_sign, okay, equal to, so we're going to use np, which is the numpy, and then we're going to initialize the sign. So np dot sign. So instead of we just using sign equals to sign, sign 2 or sign 0 or sign 1 or sign 50, we have to denote that this operation is coming from numpy. So we have to say numpy dot sign. So we're going to put that, we say 2 multiply by pi. So 2 times pi. So in order for we to multiply by pi, we say np dot pi, because the pi is from numpy. All right, so we're going to multiply by the hour, whatever hour we have, like maybe let's say 2 p.m., 3 p.m., 4 p.m. And then once we have that, since we already have the column, so this is going to apply to all the columns. So df, then we have quote in R. So this is going to apply to all the columns, not just a specific. It's going to apply to all the rows, rather. This is going to be applied to all the rows in the column, not just a specific row, but it's going to take effect on all the rows that belongs to the column R. All right, so we're going to divide by 24. All right, so once that is done, then we have to run the code. Now, ensure this is a string, so we have to put that in quotes. So r_sign, that will be in quotes, so we don't have any errors, so it doesn't throw errors. All right, so once we've done that, we've been able to successfully create that future. And then we also need to do this for sine and cosine. So we have the cos, we have the np dot cos, that's cosine. We have 2 multiplied by np dot pi multiplied by dfr divided by 24. So once we do this, we're not supposed to get any error. So the next thing we need to do, we need to perform future scaling. Now, there are 2 types of scaling, like we mentioned in our lecture. We have the standard scaler, which scales features to have 0 mean and unit variance, meaning that variance is equals to 1. And then we have the minimum maximum scaler, which scales features to a fixed range of 0 and 1. It means it will not be less than 0, it will not be more than 1. All right. So we're going to perform these 2 operations, and then you can also view the data at the end of the day to see how the result looks like. All right, so we're going to perform the first one. We're going to import this pre-processing method from Scikit-learn. So we're going to say from sklearn dot pre-processing import standard. So that's going to be case sensitive, starting with capital letter S. So we're going to say standard scalar. The scalar has also begins with a capital letter S, comma. We have the min max scalar. Okay, so once we do that, we import that method from the Scikit-learn learn library, and then next we need to perform the operation. We say the scalar underscore std equal to the method that we have called, standard scalar. So since this is a method we called, we have to introduce the open and close bracket that tells us this is the method. And then for the min max scalar, we have to also indicate that this is also a method. Okay, min max. Okay, so let's run this. If we have an error, we will check it. But successfully, it ran without any error. So the next thing we need to do, we need to apply. Okay, we need to apply this method on the data set in order for it to transform the numeric data. We need to scale it. All right, so there's a method, or there's a function in this method that is called .fit underscore transform. So this does the pre-processing, this does the transformation. All right, so it totally changed the data to a new set of data. So we're going to say df underscore, say std equal to pd dot data frame into bracket, we say scalar underscore std dot fit underscore transform. So what are we transforming? That's what we need to specify. So this is a method we want to apply. All right, df underscore std is nothing but a variable. We've applied the pd.data frame. All right, and then the method we've called for scalar, standard scalar dot fit transform, we want to apply it on our data. So which data would that be? It's going to be the numeric columns. So this is going to be df. We have the numeric underscore columns. Okay, so we apply that, and then we say that let the column, okay, the columns equal to, okay, numeric underscore columns. In this case, we're applying standard scaling to numeric columns and return a new data frame. So we're going to have a new data frame after doing this. All right, it says got an unexpected keyword argument columns. Okay, so this is supposed to be the single S, and then we've got a double S, supposed to be N and S. Okay, columns. So that's a spelling typo. All right, so we have to repeat this same method, the same style for the min max. So we say min max. So we're going to change this to the min max method, min max method, and then it follows the same suit, the same transform, and then the same method. So if we run this, we shouldn't get any error. Right, so now that we have done this, the next thing we want to do is this. Let's see what the data looks like in the first place. So all you need to do, copy the name of the variable, and then you click on the enter key. So let me copy the name of both methods we've applied for scaling. Now, remember I told you when training your model, try optimizing, try both models, and then decide which one performs better. All right, so we see that we have a standard scalar, and then if we do the same, we also have for the min max. If you notice, the date time is not part of the column anymore. Okay, date time is not part of the column anymore. That has also been transformed. It's not part of the data anymore. All right, so the next thing we need to do is let's derive another feature, which is called the apparent power. All right, so the apparent power, all we need to do is to combine. We compute the apparent power using the formula, which is the apparent power equals to the square root of the active power, the square of the active power plus the square of the reactive power. Now, this gives a more complete view of energy usage in the household. So that we're going to write it this way: df square bracket, we have the apparent underscore power to df. So this is going to be column global active underscore power. Okay. Square, so that will be double multiplication sign, and 2, that is the square, and then we have plus df into bracket global reactive and then remember, this is going to be square 2, and then we have this, the sum of the square of the global active power and the global reactive power, all square root. So all we need to do is to introduce double multiplication and 0.5, which is square root, which is 1/2. So that is how we implement this. So once that is done, we can run it and everything should go straight without any error. So once this is done, all right, so we can view, let's see what the data looks like. Now if you view this data, df, you're going to see all of this. You could see our days of the week, our sign, our course, and apparent power. Right, so we could see the df. All right, so that has been done. Now, if you notice, for standard deviation and minimax, the values are not the same. They have different values. Okay, and then we can see after introducing the apparent power, we got this. Yeah. Okay. Okay, so the next thing we need to do is to save this result. Now let's save this result. All we need to do is to say df. So df is actually the new data that we have is actually the new data that we have engineered. We have the apparent power, we have the hour cost, we have the hour sign, we have day of the week, and we have the hour. So this is the new data we're going to be saving. So we're going to say df dot to c underscore csv, okay, into bracket, what will be the name of the data we're trying to save. So we're going to call this features dot csv. We're going to introduce the code, and then we're going to say command, say index equal to false. And so once we do this, we have our results saved. Let's run. So we have our results saved. The ones that is saved, we'll be able to see it in our current working directory. Once that is saved. Okay. Still taking time. CSV is taking too long. All right, so successfully we have that. Now if we go to our directory, current working directory, we're going to see the data set called features. So at this point, we have come to the very end of today's coding, and I believe you have gained meaningful and useful information on how to carry out feature engineering. So I'm going to see you in day 4 of our machine learning project. So enjoy yourself and see you in the next video. Goodbye.